Hello, everyone. I'm Krista Tweed. I'm an applications engineer with HBK, and this video is just going to review using encoders with eDrive and cover some common questions that I get asked on a pretty regular basis. So let's start by looking at if you're using an HBK torque transducer that has an encoder included on it. You added that option when you purchased it. Very straightforward. When you buy an eDrive bundle from HBK, it includes what we call the G70 torque adapter box. And this box serves two purposes. It converts the differential symmetrical RS422 output of the torque transducer into a TTL single-ended signal that the eDrive power analyzer can support. And the second purpose is that it splits that signal so that you can send those torque and speed signals directly to your automation system rather than having it just go to eDrive. So if you're going to connect a torque transducer up to an HBK torque transducer up to eDrive, it's going to look something like this. You've got your G70 box. One side of the box has a 44-pin D-sub that connects up to your GenDeck mainframe, your power analyzer. On the other side, you're going to take the torque output of the torque transducer and put it into the torque in connector. And the speed in connector is where your speed connection will be made. And I recommend powering your torque transducer directly as opposed to powering it through the G70. Since we're focusing on encoders here, HBK's cable KAB163-6 is the part number for the speed cable that'll make that connection. Now in perception, once you've got everything connected, because it is our sensor, we already have that included in the HBM sensor database. So if I go to the sensor database sheet in perception, and I look and expand under sensor groups, torque transducers, most commonly with eDrive, people are using T40B or T12. And so if I just expanded one example of each of those, you see in each case, you've got an RPM option that is there. That is the speed sensor that's part of that, torque transducer. With the T40, you will see two different RPM sensors. One of those says 128 pulses per revolution. The other one is the 1024 pulses per revolution. And typically people doing eDrive type work will purchase that 1024 to have a better resolution on their speed. All right, now this is where all the questions tend to come in. So someone contacts me and says, I have my own encoder that I want to use with eDrive. What do I do? The first thing is to pull up that encoder's data sheet. And there are three main pieces of information that you're going to need off that data sheet. You need to know what type of output that sensor puts out. Is it a symmetrical plus minus 5 volts or a single-ended 0 to 5? So the symmetrical will typically have 2 pins outputting that plus minus 5, whereas the TTL, you're just going to have a single pin and the ground connection for each of those encoder signals. You need to know the pulses per revolution for the sensor, and you need to know the maximum speed that it can support. So in perception, the first step is going to be to create a new sensor, a new entry in the sensor database for that sensor. The easiest way to do that is to find one of those existing speed sensors, right-click on it, and select duplicate. So I'm going to jump over to perception and show you that. So if I just grab the TTL example, one of those RPM sensors, and I say duplicate sensor, now I have a sensor I can edit here. So I'm going to put, let's see, I just put in can do that. I'm going to leave the maximum speed at 15,000. And then you can see that I need to determine what this sensitivity entry is. How do I do that? The equation to determine your sensitivity is to take your maximum speed in RPM divide it by 60 to convert it to hertz, and then multiply by the pulses per revolution. So in my example, I have a 15,000 RPM sensor. I'm going to divide that by 60, and it has 2048 pulses per revolution. So that tells me my sensitivity is 512 kilohertz. So I'm going to go back to perception, enter 512. You can see the units are kilohertz, and I'm going to apply. And now that sensor is down in my user sensor database, still under HBM transducers and T12. I could move that to be somewhere else if I wanted to, but there's my new sensor that now when I go to set up my motor in the ePower suite, I will look at the motor. If I click on the speed sensor under user sensor database, sensor groups, HBM transducers, torque transducers, there's my encoder that I created, and I could then select and use it for that channel. All right, so that's how we create a new sensor for one that's not already in the sensor database. Now, what about wiring? This is where you've got to look at what type of output that encoder has. If it is a symmetrical type output, just like the HBK encoders, then you're still going to use that G70A torque adapter box and use either the speed input, either A or B side, it doesn't matter. Here's the pinout for that connector on the G70. And just to help translate the language that's there on the pinouts, the reference signal is the Z pulse of the encoder. Your rotational speed 0 is the A pulse, and your rotational speed 90 degrees is the B pulse. A lot of times on other data sheets, you'll see ABZ as your different connections. Now, if you have an encoder that has a single-ended or TTL type output, you have a couple different options. The first option is if you don't have any need for a standard G70A, you can make sure that you use or you purchase a G70A S32, which is a special version of the G70A designed for sensors that have a TTL speed output. And there's already a nice video on our YouTube channel about how to set up a T210 torque sensor with a Genesis power analyzer. The T210 torque sensor also has a TTL speed. So just search that YouTube channel for that title, and you'll find a lot of information that Mike already put together on how to connect that type of input. Now, if you also have T40B and T12s, and you need to have a standard G70, there is the possibility of using that standard G70 to measure a TTL speed encoder, as long as you don't need speed output. You don't need that signal to be split by the G70 and send that speed signal directly to your automation system. So that's the way that we do that, is that each GN310B and 610B power module actually has 4 timer counter channels. And the G70A only uses 2 of those timer counter channels per module with its standard wiring. It's designed to be used with both slots A and slot B. And so that leaves 2 available timer counter channels, and we can take advantage of that. So let's step through a few things about how this connection is going to work. To back up just a minute and talk about how the timer counter channels get connected to the GenDAC mainframe. This is just a picture of our 17-slot mainframe. Each slot is designated a letter, and you can see the mainframes will have either 1, 2, or 3 of these 44-pin D-sub connectors, and they are labeled A/B, C, D, or EF. The reason for that label is that the digital inputs and timer counters are actually supported by the modules in the slots, there's just not room on that front panel of the module to make the connection. So the connectors are on the mainframe, but these connectors can only be used if there are modules in the corresponding slots that support those channels. So typically for eDrive, you will have power modules in slots A, B, and possibly even more. So I'm just going to focus in on the AB connector right now. Everything I tell you works the same for the CD connector and the EF connector, as long as you have those slots populated in that mainframe. So the fourth timer counter channel associated with those power modules uses pins 4, 5, and 6 on that digital input connector. Pin 4 is what we call reset, that's your Z pulse. Pin 5 is the direction, that's your B pulse. And pin 6 is the clock, and that's going to be your A pulse from your encoder. And then you have a variety of pins that you can use for that ground connector. You're actually going to connect this to the what we call the loop-through connector on the G70A box, because assuming you will have a torque that still needs that differential adjustment, and you're just going to use the loop-through connector to wire up pins 4, 5, and 6 and a ground. The data sheet for the G70 tells you those part numbers for those 44-pin D-sub connectors, what's on the loop-through event input on the G70 box itself, and what type of connector could be used to connect up to that. So once you wire that in, then the question is, how do I actually choose that channel in perception? So if I go back to my motor component here, typically perception will group together when you're selecting channels for your motor input, 8 and 9 and 10 and 11. But if we need to use channel A8 for torque, I do have the ability, after I've selected A8 and A9, to come down and say, now I want to use A11 as my speed channel. And that's going to allow me to use those inputs that I mentioned, pins 4, 5, and 6, because that is my fourth timer counter channel on that GN 610B or 310B, whichever module I have. It'll have that same name. So then I can come down and select my torque, my encoder sensor that I created. There we go. And if I've got everything wired up, now I'm ready to measure that speed signal within perception. So I hope that makes sense. I always like to leave and make sure people know how to reach technical support. If you're in the Americas, you can email us at support@usa.hbm.com. If you're in any part of the rest of the world, you can email support@hbkworld.com. And if you're interested in calling us, go to our website, and there are phone numbers there for all of our contacts worldwide. Happy testing.